Hello everyone, I am Himanshu and I will be giving a brief demonstration video for ZMMFC 5.5.2, which is 5.5 digit multifunction calibrator. So first I will tell you the front panel. So using this calibrator you can calibrate AC/DC voltage current ranges, and these are the mode selections. This is DC voltage, AC voltage, DC current and AC current. To select the suitable mode, we have provided up and down keys. If I go down, it will select AC voltage. Further, when I click down push button, it will show DC current mode, AC current, and when I click up, it will show up. Similarly, for range selection, we have up and down keys, with which you can select from 200 millivolt to 1000 volt, and for current 2 milliampere to 20 milliampere. Now, since I have selected DC current, this LED is glowing. Now, when I select DC voltage, this LED glowing. Respective to voltage and current, the LEDs will glow, and using this push up and down buttons, you can select the ranges both for current and voltage. For current, it is from 2 milliampere to 10 ampere. Now, for a non-contact tachometer calibrator, we have provided a optical LED with which you can calibrate up to 60,000 RPM. If the input supply is abnormal, this LED will glow. So you will have to ensure that you give stabilized power, operating power to this calibrator. This feature is specifically added to get the accurate output voltage and currents. So we have provided a toggle switch between filter mode, which is normally used between 45 to 60 Hz, and normal mode, which is 50 to 1 kHz. You have power on off switch. Now, to set voltage and current, like now we have selected DC voltage 200 millivolt range. So if I, for example, set 10 millivolt, this is 10 millivolt. Using this decade switch, I can set voltage, whatever voltage I require. This is 1 millivolt. So from list LSD to MSD, you can set values like this for both voltage and current. Now, for example, if I go to the current range, similarly 2 milliampere range is selected, and I can set 1 milliampere or a 0.1 milliampere using this. Likewise, for frequency, we have provided for voltage and current, we have provided 5.5 digit display. For frequency, we have provided 3.5 digit display. So using coarse and fine potentiometer, you can set frequency. So since now DC is selected, it won't show any frequency. When I go down, so I will be able to set frequency as well. Now we have roughly set 50 Hz. So using coarse and fine potentiometer, you can set frequencies. Now, this particular multifunction calibrator can be operated in normal mode. For digital multimeter calibration, panel meter calibration, you will have to use the normal mode. For calibration of clamp-on meters, we will just toggle it down and use 100x100 coil mode. Along with this multifunction, we will be providing into 100 current coil, using which you can calibrate clamp-on meters up to 1000 ampere So basically this is the coil, current coil. You can see the ratio 1:100. So if I set 1 ampere, then for example 1 ampere DC if I set, so it will give me 100 amperes for it. And if I set 10 ampere DC, it will give me 1000 ampere. So using which I can calibrate clamp-on meters. So once I set the desired output which I require, we have provided a output on push button. When I push this, the output on LED will glow. This is on, output on. So basically output suitable terminals for voltage, milliampere and ampere are provided. In case the outputs get tripped, because it might be for any reason, like mistakenly if you connect it in a not proper way, or it is out of range, then output will trip. Or if the failure is occurring somewhere, then output will automatically trip. It is a safety feature. Now we have given here a chart on front panel itself, where we have provided a rotary switch which select the range from 1 to 10. Respectively, a toggle switch is provided. If I want to use the fixed position resistance, then I will toggle it to the resistor. And using this decade switch from 1 to 10, if I put it on second position, it will give me 1 ohm. On first position, it will give me 0 ohm. On third position, it will give me 10 ohm, and likewise and like that. On 10th position, it will give me 100 mega ohms. Now similarly, if I want to operate inductance and capacitance, the same table is provided over here. I will have to first toggle it to inductance and capacitance. Then first 5 positions are for inductance and next 5 positions are for capacitance. Like first position will be 10 microhenry, third position will be 1 millihenry, and fifth position will be 100 millihenry. Moving forward, sixth position will be 1 nanofarad, eighth position will be 100 nanofarad, and 10th position will be 10 microfarad. So likewise, this rotary switch. On the right side panel of 5.5 digital multifunction calibrators, there are other 2 features. First is for millivolt calibration purposes, we have provided this. It is quite self-explanatory that when you pass current and sense the voltage, you will able to calibrate millivolt. In this, we have a small resistor of 1 ohm and test current up to 200 milliampere, both AC and DC you can source. And for analog meter calibration, these 2 are the points, only for 200 millivolt AC and DC. So this is, now I will be calibrating this multimeter using 5.5 digital multifunction calibrator. So now the range selected is DC voltage and 200 millivolt range is selected, and I will just do the output on. So I will be showing the 50% points. So for 200 millivolt I will be showing 100 millivolt point. So when I set 100 millivolt over here, same is reflected. I can just change the range to 100 millivolt. Yeah, if I put it on millivolt thing, so it is fairly showing us 100 millivolt. So can be said that it is quite accurate. See, the display resolution over here is 3.5 and we provide 5.5, so you get 100.000 displays 100.0. So I will now put the output off and select the next range of 2 volt, and I will show you now 1 volt. Similarly, from millivolts to volts I have done on the multimeter itself, and I put output on. It is fairly showing 0.999, which is approximately 1 volt. Now when I go to 20 volt range and I set 10 volts, it is showing 10 volts. Now when I go to 200 volts range and set 100 volt, it is showing 100 volt. Now before going to 1000 volt, I will put output off, go to 1000 volt, and I will show 500 volts over here. I will put output on and gradually increase the voltage. Like if I set 60 volt, it will show 60 volt, and let's say I set 150 volt, it will show fairly 150 volt, and I will go up to 500 volt. It is showing 499.9 volt. So this is about DC voltage. Now the next range we will go for is AC voltage. Next parameter is AC voltage. So range is 200 millivolt. I will set output on and check 100 millivolt. So yeah, it is showing 100.1, which is well within accuracy. Now I will go to 2 volt and set 1 volt over here. It is showing 1.002, which is well within the accuracy. Then for 20 volt, I will set 10 volts. It is showing 10 volt for AC. Now for 200 volt, I will set 100 volt. It is showing 100 volt. See, for 1000 volt, I am taking precaution. I am putting the output off first, then going down, and then gradually increasing the output. See, if I set 10 volt, it is showing 9.5 something. Now I've set 500 volt. It's showing 500 volt, 500.7 or 6 it is showing, which is quite well within accuracy. Now I will set output off. We will now check the current parameters. Immediately it will shift to the current thing, and I will have to now change the connections. So from voltage, I am going for current. First we will check for milliampere. Okay, so on multimeter I have set AC milliampere. We will go down, we will check for AC 2 milliampere. I will turn the output on and we will check 1 for 1 milliampere. It is showing roughly 1 milliampere itself. Now I will go to, when I put down, it will go to 20 milliampere. 10 milliampere is set, 10 milliampere. Now for 200 milliampere, I will set 100 milliampere. It will show 100 milliampere. And now for 2000 milliampere, which is 2 ampere, I will have to change the connections again from milliampere to ampere. Over here I will have to change the connection from milliampere to ampere, because 2000 milliampere is 2 ampere. So I will go down, select 2000 milliampere range, and then set 1 ampere, which is 1000 milliampere is 1 ampere. So yeah, it is showing 1.000 2 ampere. So basically 1000 milliampere, 2000 milliampere range, I have set 1000 milliampere. Over here it is showing in amperes. Now before going to 10 ampere range, I will have to change connections again from milliampere. On this calibrator as well, I will have to put it in ampere, and over here it is already put in ampere, connected it to ampere, sorry. So now I will put output on, select the range of 10 ampere, and let's say I set 5 ampere. So it is showing 5 ampere. I can go up to 9 ampere as well, so it will show. As I mentioned for AC current, similarly you can calibrate for a DC current for all the ranges. The operating process will be same, only the necessary connections you will have to make and set it from AC to DC current. I mean, in this range only you have both. In this particular multimeter, this is AC and DC. Only you have to make the necessary connections to get the actual reading. So this is about all voltage and current parameters, and using this multifunction calibrator you can calibrate this 3.5 digit. Now using this multifunction calibrator, I will show how to calibrate non-contact type tachometer calibrator. First you will have to select any of the AC ranges, and using coarse and fine potentiometer you can set frequency. So basically any frequency set into 60 will be RPM. So if I set 50 over here, so if I set 50 roughly over here, so 50 into 60 will be 3000, and same I should get roughly 3000 RPM I should get once I point it to the see. So it is showing 50.1 into 60, whatever the answer will come will be near to this RPM which it is showing. So that is how you calibrate non-contact type tachometer calibrator using this device. Now I will tell you how to calibrate analog meters. This is Make analog ampere meter, DC analog ampere meter. So here you can see at 75 millivolt it will show the full scale reading, which is 60 ampere. So 75 millivolt DC I have to supply. I have set it like that, and once I say output on, it is showing roughly 60 ampere. 75 millivolt I have used 200 millivolt range, in which I have set 75 millivolt using this decade switches, and it is showing 60 ampere. That is how you calibrate it. If I reduce it, approximately the current will get reduced. Like for 55 millivolt it is showing somewhere around 42 amperes. So like this you will be calibrating analog meters, and the connections as discussed earlier are on the right side. So this is how you calibrate analog meters. Now I will be explaining the AC/DC millivolt measurement using this 4-wire method. So basically it is used to calibrate the lower voltages like 1 millivolt, 2 millivolt, like that. So what we do is, I have set here AC current range. Basically I have set 1 milliampere over here. Similarly, milliampere connections, these are the sourcing points. I have given 1 milliampere sourced over here. and I am sensing the drop across the resistance value, which is 1 ohm. So the drop is shown on the multimeter, which is 1 millivolt. This is just an add-on feature which is provided by us, and you might find it useful during time of audits. Now if I set roughly 2 milliampere, it will show 2 millivolt drop similarly. So basically it is used for calibrating very lower voltages like 10 up to 10 millivolt, 20 millivolt. You can calibrate using this method. Now we will see how to calibrate clamp-on meters using current coil. I have set the mode to DC current and range is 10 ampere, which is already selected. I have put the output on. I have made the necessary connections from ampere and common to high and low of this current coil. So I have set 1 ampere. 1 ampere will correspond to 100 ampere. So it is showing 100 ampere. Now if I change it to 2 ampere, it will show roughly 200 ampere. Likewise, we have to calibrate. Like if I set 6 ampere, it will show 600 ampere. So basically this is also having a range, 400 ampere reading and 2000 ampere reading. So as soon as I set something which is above 400 ampere, basically 600 ampere I have set. So I will have to select this 2000 ampere range, and it is showing 600 ampere. So like this you can calibrate up to 1000 ampere, and for 1000 ampere you will have to set it like this. This is roughly 10 ampere, fairly 10 ampere. So yeah, so it will show 1000 ampere over here. So like this you will calibrate for both EC and DC current ranges. Similar processes for AC current ranges as well. You have to do the same connections, just you have to change the mode. So this is how you calibrate the clamp-on meters. Thank you. Now we will see how to use this fixed position RLC points to calibrate this multimeter. So I have set one position which is 0 ohm. I have made the necessary connections first. So I have set one position which is 0 ohm, and it is showing 0 ohms roughly. So when I go to second position which is 1 ohm, it will show 1 ohm. Third position will be 10 ohms, 100 ohms, 1 kilo ohm, 10 kilo ohm. Similarly, up to 100 mega ohms you can calibrate. Now for inductance and capacitance, I have selected this inductance and capacitance. I'm using this LCR meter to show how to calibrate the fixed points. So this is now one position for inductance. So first position is 10 microhenry. So similarly 10 microhenry it is showing. Now I have set the fourth position which is 10 millihenry. You can see I have set the fourth position over here which is 10 millihenry, and same it is showing 10 millihenry. Fifth position is 100 millihenry, and same 100 millihenry it is showing. Now I will show you how to use fixed position capacitors to calibrate the LCR meter. So right now I have put this rotary switch on 6th position. 6th position is 1 nanofarad, as you can see, and it is showing, similarly it is showing 1000 picofarad on LCR meter. Now if I go to 10th position which is 10 microfarad, on LCR meter it is showing 10 microfarad. If I go on 9th position which is 1 microfarad. On LCR meter it is showing 1000 nanofarad, which is 1 microfarad. So this is how you can use the fixed positions RLC points to calibrate LCR meters and as well as the digital multimeter. For this particular process, it is not mandatory to switch on the calibrator. That is all. Thank you.